Hi, I am good at Latin and I will be going over math knowledge today. So let's start. Okay, so the first part of math knowledge is understanding how exponents are. Exponents are going to be these little numbers right here. This is an exponent. They can come in any shape and size, which we'll be going into detail down here, which they are. They're usually used to demonstrate products of repeating factors. So if we were to do x to the third or x to the fourth, it'd be x times x for x to the second power, or if we're going to go x to the fourth, x times x times x times x. It's literally going to be the first number being repeated this many times. So n is going to represent the number of times that x is multiplied by itself. Now there's multiple ways that could show up on the test on how to use an exponent. So let's talk about the first one, which is products of powers property. So products of powers property is used when you want to multiply the powers with the same base. So let's say we want to multiply a to the fifth times a to the seventh. Well, if you've noticed, they have the same base. So if they have the same base, what you want to do is add them together, and that's gonna be the general way of how to multiply. If the base is the same and they're being multiplied, you add the exponents together. It's gonna be a little complicated, but it's something you just have to practice and get used to recognizing which one's which. So the product of a power property is used to find the power of a power. So let's say we get this. This is an example. We can do a squared to the fourth. Well, it's a little different because it's not like a squared times a to the fourth. It's actually a squared raised to the fourth power, which means what you want to do is you're going to want to multiply these two products together, or these two powers together, which will give you a to the eighth. So reiterating, let me put this right here so that I don't know I actually erased it. A squared plus a to the fourth, which makes it to 6. Sorry about that. Going to add this. Alright, so whenever you have a exponent raised to another exponent, you multiply them together. So let's move on to the next one, which is the power of a product property. What you want to do is, so this is an example. I'm going to give you a plus b. Okay, so whenever we want to find the power of product, we need to find the power of each factor separately, and then we're going to multiply them together. So basically, this one's a little bit basic, I think. It's just literally just a 3 or a 2. I don't even know. It's a 3 to 9. That's a B, by the way. Yeah. So this one's also really simple. It's actually probably the easiest because if your exponents, or if your product thingy right here is being raised to a certain exponent, you just put it in for each one and that's it. I mean, I think you would then use the product of powers property, but no, you wouldn't even use the product of power property because the bases are different. So usually use this if the bases are different because they can't be added together. So yeah. Let me erase this now. Oh, that's not the eraser. Okay, that's good enough. Alright, so now we're going to talk about the quotient of powers property, which is when you want to divide powers of the same base. So it's almost similar to the product of powers property. So let's say we get a12 divided over a8. Well, their bases are the same, which means that we can subtract these together. So 12 minus 8. And then we're going to get a to the fourth. That's a very nasty a. So if you were to ask me what is a to the 12th divided by a to the 8th, I would tell you it is a to the 4th, because of the quotient of powers property allows you to subtract them as long as the base stays the same. If we were to do the power of a quotient property, we would use pretty much the same thing that we would use with the power of a product property. So if we get a over b, which is 7, a over b to the 7th power, we would just translate that 7 in and get a over 7 over b over 7. Because these properties or these bases are different, we can't really do anything with them. Like, we can't simplify them, we can't add them together, we can't subtract them. Like, that's the answer. Whew. Okay, some also pretty other things to just note about exponents is what happens if you get a 0 power. Well, if you get a 0 power, anything, so I'll give you an example, 12 to the 0. Anything equaled 0 is equal to 1. So if your exponent is 0, it will equal 1. If it is a to the 0 power, it equals 1. No matter what, if your exponent is raised to the 0 power, it is equal to 1. And that is something that they can trick you on. If your exponent is raised to the first power, well, your answer is a little different. If any number raised to the first power is equal to the same, because it's just going to be 12. There's no multiplication to it, it's just 12. So, any number raised to the 0 power is equal to 1. Any number raised to the first power is equal to the same number. But what about negatives? Well, negatives are a little different. So let's say we get a to the negative n. Well, what you want to do is you're going to find the reciprocal of a, because we can't have negative exponents. So the reciprocal of negative 1, or negative n, which is just a number, is going to be a over n. But whenever you find the reciprocal, you also have to put it over 1, which gives us 1 over a over n. If I were to give you, let's say we do a to the negative 4th. We find the reciprocal of that, which would give us 1 over a to the 4th, because we need to get that negative out of here. I feel like that one's pretty a little complicated, but also, just understanding the rules will help that a little bit easier. Is there anything else I think we should know about exponents? Okay, so something to also notice is understanding where the parentheses are. So if I give you 2 to the 3rd, that's just going to be 2 times 2 times 2, which equals 8. Okay, that's very self-explanatory. But what if I do negative 2 to the 3rd? Well, negative 2 times negative 2 is 4, times negative 2 is negative 8. So understanding that this negative right here and this parentheses plays a very crucial factor in what your answer is. Just letting you know. And if it's like this, negative 2 to the 3, it's still going to be negative because first you're multiplying these numbers first, so 2 times 2 times 2, which is 8. But you still have that negative to draw over, so it is going to be negative 8. But just be cautious of where you're putting those negatives and understanding how to use them. Okay, roots. So roots, there's 2 types of roots, or square roots. These are called the perfect and the imperfect square roots. Perfect roots look like these. 4, square root of 9, square root of 25, square root of 36, These are called perfect roots because they can be summed into these numbers. I forgot about the square root of 16. 4, 5, 6. Perfect roots are just numbers that when you take the square root, the result is an integer. So 1, 4, 6, 9, 16, 25, 36, 49, 64, 81, 100, so on, so on, so on. Now, these are very basic and probably the ones that you see the most because you're moving quick. So I think these are pretty fine to understand. But what if you get an imperfect square root, like the square root of 45? Well, we all know that the closest square root is 49, which means this is an imperfect square root because you would need a calculator. But there is still a way for you to find what exactly, or how to simplify it without a calculator, and that is to find the multiples of the imperfect square and understanding, okay, is there a perfect square in this? So when I look at 45, like, when I look at 45, I know it's going to be 9 times 5. Well, the square root of 9 is a perfect square, so this would actually give me 3. So if you're asked to simplify for the square root of an imperfect square, find which multiples give you a perfect square number, which in this case would be 9, and you would, anytime you have the square root, you put that on the outside. So if I were to tell you to simplify the square root of 45, we would get, in this case, I'll show you how to actually do it. So it'd be like this: 9 times the square root of 5. If we were told to simplify it, but since 9 can be simplified into 3, the answer becomes 3 square root of 5. So anytime you're asked to expand this again, understanding that the outside number has been square rooted, so you would have to square root that, or put it in a square and put the thing over it, and then do what you need to do to get that done. Now, if they didn't tell you to simplify it and told you like which numbers are there, in the middle of, you could say the square root of 45 is in between 6 and 7, because the square root of 45 is in between the square root of 49 and the square root of 36. Well, the square root of 36 is 6, the square root of 49 is 7, which means that the square root of 45 has to lie within these number range. So there's also another way to figure that out. Now, all positive real numbers have 2 square roots. That is something to let you know, which is why we get, I'm going to actually erase this real quick. Erase as much as I can. Okay, so what this means is whenever you square root a number, in this case, square root of 25, it has to have a positive and negative number, which we write it as this, the positive or negative of 5. This is why when you do the quadratic equation, you have the x equals negative b plus or minus, because you're square rooting a number. So plus or minus the square root. And anytime you get a square root, understanding that there is a positive and negative number. Just something to know. Next one. Okay. Oh, I am thirsty. Okay, so there's 3 types of parentheses. We have the very common parentheses, the brackets, and I forgot what this is called, but usually they don't have it where they don't do this in equations. They don't go like x plus x. They don't do that because it's a lot more complicated to look at. So what they do is they can go like this: x plus y. It signifies that they're each different parentheses and things to understand, which shows you that, okay, well, I need to work on this one first, then this one, then this one. They will never really use all of the same parentheses just because it's very confusing. So if I were to give an example of how parentheses work, let's do 10 minus, let me use this bracket instead. They don't really use the third parenthesis that much, but just for the sake, I am going to use the third one. So 10 minus 5, oh, I lied, boop, 5 plus 2 times 1. Well, you would have to solve this, so it's very simple to understand to solve it. So if we were to put this out in steps, 10 minus 7 times 1. I hope I got it'd be so bad if I mess this up. Okay, so first you would solve the first parenthesis, which is this. And once we get 7, technically you can just get rid of this parenthesis. And now work on the second parenthesis, which is the bracket. Which you would then get 10 minus 7, which you're then able to erase this bracket and understanding 10 minus 7, which gives us 3. You could very easily mess up these parentheses by doing your operations or your parentheses wrong. Very easy to mess up, but just be very mindful of how parentheses, the types of parentheses and how they work. Order of operations. We all know PEMDAS. I think it's called GEMDAS, like grouping, but I use PEMDAS, which is just parentheses, exponents, multiplication, division, addition, and subtracting. So, I'm going to put that there. Squared. Okay, so PEMDAS. Couple things to note. When your multiplication and division are right next to each other, your addition or subtraction are right next to each other, you move from left to right. So if I give you, let's give you this example right here of an example. So this divided by 3 plus 2 times 7. So the first thing you need to understand is that just because multiplication goes in front of division, if they're next to each other, like this, and you don't have to do any parentheses or exponents, you move from left to right. So you would move 2 first plus 14. Now, in this case, it's not really like a big deal because you could do them back left to right or right to left because of that addition which separates them, because you still have to do both of them before you add them together. But let me see if I can find another example. We can do, well, these are already not hard examples. We'll just do it. Okay, so this one's going to be 2 times 3 to the squared plus 5. Well, the first thing we notice is that there's an exponent, so we do that first, which gives us 9 plus 5. Well, now we need to do multiplication, which is 18 plus 5, and this gives us 23. So, very easy to understand in concept, but just be careful of how like your parentheses and your exponents and all that will work. Absolute values are a little bit different. Any number designated by this symbol right here, any number designated by this symbol right here is going to be an absolute value. So A equals A because it will be positive. But what if you get a negative number? Answer still positive because you're finding the absolute value. But what if you get negative with the absolute value? Because we're only focusing on what's inside of the absolute value, the answer actually becomes negative A because A itself right here is positive. But we still have to add that negative, which is outside of the absolute value, so we can't really make that positive. So the answer would actually be negative. But because it's not in the sign, it still follows that rule. Just something to take notice of. Next. So I do want to go over something, but I'll do that toward the end. So we'll just keep going. Polynomials are going to be just a way to comprise of terms. These can be in the sense of monomials, polynomials, etc., etc. So this the equation on the screen or the slide is an example of a polynomial. Something to take notice of is this what is a leading term? A leading term is going to consist of the highest exponent power. Understand that we can have this shifted any way we want. We could have it look like this. 3x5 plus 10. We could have it look like this, and it wouldn't be a problem. Now, if I were to ask you what the leading term is, understand that it is not negative 4 to the third. It is still going to be 3x5, even if it's in the back, because it has the highest exponent. You also need to understand that coefficients are just going to be the letters, or these numbers. So, yeah. Also, it is very customary to organize them from highest exponent to lowest exponent, but if you get an equation that's not like that, it's still fine. Let's see. Okay, so we can combine polynomials with like terms. So let's put this right here real quick. Give me a second. 9a3 plus 4a2 plus 8. Alright, so we can combine this polynomial. So we would get the fact that, let's see what we got. My handwriting is really bad, but that is okay with me. Okay, sorry about that. So we're going to combine these by like terms. So a to the fifth, same base, we can add those together. So that'd be 3a5 plus negative 8a5. We can combine this base with this base, so we can also combine negative 9a3 plus 8a3. 4a to the squared and 2 does not have anything to be combined, so we will drop them down anyways. So adding these two variables next to each other, we get, let's see, what's that, negative 5a to the fifth minus a to the third plus 4a to the squared plus 2. Yeah, that is correct. So whenever you try to combine like terms, just understand as long as they have the same base, you can do whatever you want with them because of the exponent rules that we're talking about. Okay, I think we all know what FOIL is. FOIL is the act of first, outer, inner, last. So if I give you this one, x squared plus 5x, 3x4 plus 2, we'll use the FOIL method. So what this means, first, then outer. Let me write this down in another. So this is first, and this is outer, inner, last. Inner. So that is FOIL. We use the first exponent. So in this case, we would do first, which is x squared times 3x to the fourth power, which gives us 3x to the sixth power. Then we do outer, which is x squared plus 2, which is going to be 2x squared plus 3x times 3x to the fourth power, which is going to be 15x to the fifth power. And the last, which is 5x times 2, which is going to be 10x. We will then rearrange this just to make it a little easier. So 3x6 plus 15x5 plus 2x plus 10x. Boom! And if I wanted you to simplify this, you could really take out an x out of all these and be fine. But that's not really the point. So that's how you do FOIL. You usually use FOIL for a lot of things, a lot more things than you think, as when you see a polynomial. Okay, so how do we factor a polynomial? I got you. 9x 4 plus 15x squared plus 3x. Well, what I'm going to tell you is let's look at the coefficients first. So let's look at the 9, let's look at the 15, let's look at the 3. What is the number we could take out of all three of those and factor? The answer is 3. But let's look at the coefficients. I believe it's got coefficients. I forgot already. Let's look at the x's. What is something we can take out of all of these and be fine? Well, the answer is x. So if I were to tell you to factor this, take out 3x, which would give you 3x3 plus 5x plus 1. This is a very simple method of factoring these. Sorry, my nose is freaking out. Okay, this is one way to factor. You can factor other ways, but usually it's easier to take out the x so that you can kind of have a little bit easier time looking at it. So this is the most simplified form, I believe, of this polynomial. Excuse me. And this is also considered the greatest common factor of this polynomial. There's a couple ways to factor special types of polynomials, which I will briefly go over. I don't really like going over these in general, I'll be honest, but I will go over them really quickly. So, first thing, we have a perfect square trinomial. A perfect square trinomial can be used in situations like this. 2xy plus y squared, x1 minus 2xy plus y squared. So, perfect square trinomials can be shaped in the way that they can be simplified into this manner right here, or x minus y. And the reason you can do this is because if you use the FOIL method, I believe, like let's just say x plus y squared root is x plus y. Well, we're going to get the fact that x times x is x squared. They're the same figure, so x times y is going to be xy times it by the fact that there's two of them, gives you plus xy. Y squared is plus y squared. So the perfect square trinomial is honestly a beautiful thing, I'll be honest, but I still don't like learning all these special cases. The next one to know is the difference of squares. The difference of squares is when you get x squared minus y squared. X squared, okay, that's okay, I'm just going to put them in parentheses. X squared minus y squared. Well, this answer is going to equal x plus y, x minus y. This is going to always be true. This is just how they work. So, if you wanted to figure out how did we get from here to here, I'm going to go x plus y, x minus y, which gives us x squared, x times y is negative xy, y times x is plus xy. My y's and my x's look the same, jeez. Minus y squared, these cancel out, which leave us with the iconic x squared minus y squared. So the differences of squares will always have this end result. So like what I'm going through right now, it should stay true for almost everything. Next one. What about the differences of cube? I hate these. The differences in sums of cubes work pretty much the same. So, I'm gonna add this real quick. Give me a second. X minus y, x squared plus xy plus y squared, x squared minus y x. Okay. Minus xy plus y squared. And this will be x plus y. You can understand, so this is the difference of cubes output DOC, and this is the sum of cubes which output by SOC. This is going to be a difference of cube because first off, your x minus y is negative, and then your polynomial is going to be positive. Your sum of cubes is going to have the addition in the first sector, and then its first number is going to be negative. If you were to multiply x times y by the or x minus y by this polynomial, you're going to get your difference of cubes of x squared minus y cubed, or x cubed minus y cubed, because this is going to factor out really quickly. Like, it will factor out fast. And yeah, it's pretty, like, not something it's something important to know, but you know, you could always just, as long as you know you can factor it out, you'll get the answer pretty quickly. Let's get with the, yeah, I'm not doing that last one. The last one is the perfect cube trinomial. I will show you the equation, but not once have I on any SAT, ACT that I've ever seen this equation, because it looks like terrible to look at. I've not once seen this on anything, so just this big number is not really important. If you were to multiply x plus y 3 times by itself, you would get this big monstrosity. So, next slide. Okay, so we're going to go over linear equations and inequalities. So, linear equations are going to be equations where the exponent of the variable is 1. Now, they can have one variable, multiple variables, and they can be solved in 1 step, 2 steps, or multiple steps. They can come in a lot of shapes and forms and have different letters, so be prepared for that. And yeah, so if I were to give you the first one, which is 3x minus 10 plus 4x equals 5x minus 12. This is a one variable linear equation because it has only one variable, x. We're going to solve it real quick. So we're going to first add these exponents on the left side. And now my rule of thumb is I usually try to keep my x positive, or I try to keep my variable positive, so if one side is clearly better than the other, I'm going to subtract or add the weaker side to the bigger side, which gets us 2x plus 10 plus 10 negative 2 to x equals negative 1. So this is like a really fast way for you to solve it. Just really go down really quickly, answer them out, simplify them together, try to keep that x positive, because especially when you're dealing with inequalities, having an exponent that is negative and having to divide, the x negatively flips that, inequality side, and it can get really confusing sometimes. So now let's say we have if you continue reading this first line, it says, if the variables are not completely cancelled out, check to see the coefficients if it is true or not. So I will show you two types of equations. So let me do this. Let me write. I need to freaking write better. 2x plus 10 equals 2x minus 5, and 4x minus 2 equals 2 equals 2x minus 1. So, we were to solve for x. The first thing that's very obvious is 2x cancels out completely, which leaves us with 10 equals negative 5. First off, 10 does not equal negative 5. That's wrong. So, because 10 equals negative 5, this statement is not true, and there's no solution to this linear equation. But what if we get something like this? Cancels out. -2 equals -2. That's true. -2 does equal -2 because that's how numbers work. This means that this statement is true. Therefore, any value that we substitute for x will result in a true statement, and there's an infinite number of solutions for this linear equation. This means that the solution is infinite. Just going to erase this now and get to the next one. Erasing's so bad. Okay, that's good enough. Now, let's look about what if we get two variable equations. This is where we get into the whole coordinates, which is your ordered pairs x, y. Now, this is where we're going to get our rise over run. So slope, which I will, everyone talks slope is m. So slope is going to be rise over run, rise over run, or in this case, y over x. Now, whenever you are trying to find slopes, you want to use this formula, which is, I believe, called should be slope. So m is equal to the change or the difference of y over the difference x, which in this case is just going to be y2 minus y1 over x2 minus x1, where x2 is going to be x comma y 0.2, and y1, y2 is just going to be the first point that you use. If the line is a horizontal line, the slope is 0. If the line is a vertical line, the slope is undefined. These can be positive or negative, and if the slope goes like this, it is positive. The slope goes down, left to right, it's a negative slope. The y-intercept is going to be the point in which the line touches or intersects the y-axis. There are x-intercepts, which if I were to keep drawing this line, this will be the x-intercept. You can find the equation, if you're given a graph, you can find the slope pretty easily by doing rise over run, which is also why we do the x1, x or y1, and then this is where you get the x2, y2, which is how you find that slope as well. There is a few different ways to write a linear equation, so I'm going to show you some ways really quickly. Also, I'm just going to show you some equations which are on the on the point. The PowerPoint has some equations that I'm going to write down that you should know. So the slope-intercept form. This is the form where you know the y. So this is where you know the y, which is the intercept, which is also going to be labeled as b, by the way. So this is where you know what the y and the slope is. So this would be y equals mx plus b. Very standard, very easy to figure it out. But what about the standard form? Well, the standard form is going to be ax plus by equals c, where that is crazy. Okay, this is c, where c is going to equal a, b, and c are constants, and you can find the slope by dividing your a over your b, and you can find your y-intercept by dividing your c over b. From there, you can then figure out, oh, y equals mx plus b. And this is because I think I'll try my best, but the reason why you can find your slope is because first off, there's your y, so by equals c minus ax or something like that. Divide this whole thing by b, which would give you y equals c over b minus ax over b. Or in this case, you know, slope right here, and your y-intercept right here. So just something to do, but honestly, if it's easier for you to just bring the y by itself and solve everything, you don't have to worry about like the particular form. Just whatever's easy and works best for you is all that matters. Your 2-point formula, your point slope formula are the same, pretty much. Your point slope formula is going to be y minus y1 equals mx minus x1. Now, your slope is still m, and your x1 and x2 are only 1 point. This is really used, I believe, when you're trying to just find just an equation. Like it's only used if you know just 1 point and the slope. But let's say you don't know the slope at all, and you're trying to find the slope. I think, yeah, this is where you're trying to find the slope. y2 minus y1 over x2 minus x1, which would give you your slope, which you could then use your slope to figure out what, did I finish this? No, I did, yeah. You can then use this slope to find your b, which is your y-intercept, because these usually aren't your y-intercepts. And use it to find your y-intercept, which will then be used to find your equation of the entire line. But what about intercept form? This is only when you know the x and y-intercepts. So x over x1 plus y over y1, where x1 and y1 are going to be your x and y-intercepts. So that's interesting to know. Now, that was a mouthful, but I got through it. So now let's talk about inequalities real quick. Just really quickly, I think pretty self-explanatory. This is this is greater than, this is greater than or equal to, this is less than or equal to. Pay attention to where the x is, because if your x looks like this, they mean the same thing. X is greater than y, x is greater than y. Pay attention to where that x is, because sometimes it's asking for where the x is. And if your numbers are like x is greater than or equal to 7, and then something happens and now it looks like this, x is still greater than or equal to 7. Just because that sign is usually signaling that it's less than, depending on what the question is asking and where your x is, they mean the same thing. So pay attention to where that is. Something to note, any inequalities is, let me just draw a little line real quick. Anytime it says greater than means open circles. If it is equal to, it has a closed circle, which I'm going to try to close on my best. So if it is greater, let's say this is 3. If x is greater than 3, it's going to be an open circle and it's going to go in this direction. If x is greater than or equal to 3, it will be a closed circle and it will go in the same direction. Now, let's say x is less than 3, which I'm going to put 3 over here. If x is just less than 3, it's an open circle and goes in the negative direction. If x is less than or equal to 3, you cover that circle and you still go in the same direction. Understanding that if there is a graph or anything in general, equal to has a closed circle, greater, or just if it has no bar line underneath it, it's an open circle. One final thing to note, I know I keep saying that, and I know this is a long video. Negatives. Pay attention to the negatives, because they will trip you up. If I give you negative 3x 9, any number that is divisible by a negative, if it is divisible by a negative, the inequality sign will flip. It has to flip. So now, even though it's originally supposed to be x is greater than 3, or negative 3 in this case, because of the negative sign, it flips the inequality, which makes x now less than negative 3. This is true for anything. If that x is divisible by 3, or divisible by a negative number, the equation will flip. It will have to flip. So just something to be very careful of is that equation will flip. Okay, so what about these systems of equations? Now there's two types of systems of equations. You have substitution and elimination. I'm going to show you each method kind of quickly because it is getting a very long video now. So I'm going to do something like this. You will understand which one goes better with which just as time goes on. So elimination is the process, substitution is the process of substituting an equation into the number. Elimination is the process of eliminating that top from the bottom fraction to completely get rid of one variable. So let's start with the elimination method because I like it more. We can eliminate something easy. We can eliminate the x's. And the way we can eliminate the x's is by multiplying the number, this entire equation, by negative 3. Well, when I multiply this entire equation by negative 3, I'm going to get this. X plus 5y equals 25, negative 3x plus 6y equals 30. Well, now we're going to add this entire equation by each other. So we're going to get 11y equals 55. Well, that actually did really perfectly. So yeah, we're going to get 11y equals 55. We now divide for our y, which will give us 5. We still need to figure out what our x value is, so I like to figure out which equation is easier for me to solve. In this case, it is the base equation of x minus 2y equals negative 10. We plug in, now that we figure out our y, we're going to plug it in. So negative 2 times 5 equals negative 10. Because negative 10 and negative 10, we know that adding them together gives us 0. So x equals 0. If you wanted to see if this worked, you would plug this into the same equation or a different equation. So in this case, just to make sure I'm correct, I'm going to plug it into this top equation right here. And now I understand that my substitution is correct because this answer holds true. So that is how you do elimination methods. But what about substitutions? Just give me a second to erase this all. Okay, so what about substitution? Substitution is the process of incorporating an entire equation into another equation. You really only want to use substitution if it's like a very easy number, like just x. So in this case, I'm going to set everything equal to x. So this equation will then become x equals 2y minus 10. We now technically know what x is, so we're going to plug it into this equation up here. 2y minus 10 plus 5y equals 25. Solve for y real quick, and we get negative 30 plus 5y equals 25. 11y equals 55, y equals 5. Now that we know what y is, we can solve for x, which is the equation we had made in the first place. So now we get x equals 25 minus 10. X equals 0. Do you understand how just the methods depend on which one is easier? I prefer to use elimination because it's more, to me it's easier for me to understand. I sometimes use substitution if it's only going to have like x or y. It's just, it looks easier. Or if it divides easy, I will do it. So that's pretty much how to do systems of equations. Sorry. But now let's talk about cross multiplying. Cross multiplying is when you have an exponent or a fraction that is set to equal to another fraction usually. These are going to be types of proportions or ratios, and this is when you want to cross multiply. So that is how you cross multiply. I call it the butterfly method. That's how it's just ground up. In this case, you would do 2x equals 20, which x would then equal 10. Another one, let's do this r plus 4 over 3 equals r over 5. We're going to cross multiply these, so now we get 5r plus 4 equals 3 times r. 5r plus 20 equals 3r, which will then give us 2r equals negative 20. So divide that by 2, r equals negative 10. There's multiple ways to cross multiply, but understand usually you cross multiply when you have that equal sign. Or unless when you have the equal sign. You can do that with a denominator too. You know, the denominator's there at the bottom, the x is at the bottom of the denominator. You can still cross multiply. So let's get to the next question, because it's a really long video. I have 2 more things to talk about, but one more thing outside of the word given problem here. So I'm going to do the one that I want to talk about a little bit before finishing up. I forgot to talk about it earlier, but rational expressions, usually they're called rational expressions when they're divided by each other. So in this case, this is a rational expression. Why did I mess up? Okay. Right here. So this is a rational expression, which I'm actually like this negative. So what is something that can be, what is the GCF of 10x squared minus 5x? Well, 5x. So 5x over 5x, 2x minus 1. Cancel these out, and your rational expression now becomes like so. But these can come in all shapes and sizes. They get really hard sometimes, which require a little bit of like thinking, I would say. Now let's look at this one. There's also another rational expression, which is x plus 3 over 4 divided by 2x plus 6 over 3. Well, we know how to divide by fractions. Keep, change, flip, 2x plus 6. Now, before we solve this, let's take a look at this equation just a little bit more and understand that, whoa, 2x plus 6 is also 2x plus 6. X plus 3. Well, that makes our lives just a little bit easier, doesn't it? Because we can cancel these out because they'll divide by each other and they cancel each other out. Which gives us the new equation of 1 over 4 times 3 over 2. Which allows us to bypass that whole fraction part and be like, oh, thank God it's only 3 over 8. Just a little bit easier. One final thing that I will go into a little bit of detail. Sorry, I'm going kind of fast. This is about to hit the hour mark, and that is absolutely insane. So yeah, we have this last one, which is going to be x plus 5, or my bad, 5x plus 10 over x minus 3 times x squared minus 3 over x squared minus 9, my bad. X squared minus 9 over 5. Here, let's see. Let's do the same thing we've been doing these past times. 5x plus 10 can be simplified if we take out 5, which becomes x plus 2 over x minus 3. Oh, why did I do that to myself? Alright, but what about the top one? This is a perfect square. X minus 3, x plus 3 will give you x squared minus 9. This is what a perfect square is. If you want to understand why, I can do it real quick. Minus 3x plus 3x plus minus 9. Cancel these out. Gives you x squared minus 9. So this is a perfect square. Anytime you have an equation where it's x squared minus a perfect square, it will always be, this is the difference in squares, I believe it's the x minus number, x plus number, so x plus or minus the number in fractions. Which gives us, turn those please, this beautiful equation on the top numerator, which allows us to safely cancel out just a little bit of fraction, or just a little bit more, which will give us x plus 2 over 1 times x plus 3 over 1. These have the same denominator, so we can put them in like this. Plus 2x plus 3 over 1. We can take away the 1, so our final answer would be x plus 2, x plus 3. Just a little bit easier way to divide stuff. But enough of this rational numbers, let's get on with the types of word problems that we have. So there is 3 types of word problems that you can have. There are 3 types of word problems that can't show up. I'm not going to say that these are the only word problems that you have. These are some that probably show up really common. Scroll. We have distant word problems. Now, distant word problems are a little different. Usually, they're going to have some BS number. They're going to talk about random stuff before finally saying, if the trip is 480 miles and it takes them, they are driving at 60 miles per hour, how long will it take? So, first off, very easy to understand. 480 miles per hour, or miles just in general, equals the fact that they're moving at 60 miles for every hour, which is x. We don't know what that hour is. Solve for x, divide by 60. Very easy to understand that your hours, or x, is it's 8. So, usually those are very easy. You just set them equal to each other and solving for x. Percentage word problem is also something we just went over in arithmetic reasoning as well. You're just going to find, so like it's going to have some BS blah blah blah, and then it's going to say, like in this case, Alan took a math test and answered 78% of the test questions, tests correctly. If there are 45 questions, how much did he get right? Well, we don't know what his percentage of 45 that he got right, which is x, but we do know that he got 78% of 100 correct. So send those equal to each other, we get 100x equals 3510, divide that by 100, means that he got about 35 questions correct. But if they're asked for the exact decimal, he got 35 and 0.10 correct, which probably means he just got some extra credit. Now, the system equations is a little bit different, but still pretty easy. When it is basically going to say stuff like in this case, Sam bought 4 shirts and 3 pants. So 4 shirts, 3 pants, that totaled up to be $181. Jenna bought 1 shirt, 2 pants for $94. How, if the pants and shirts are all the same price, what is the price for each pair of shirt and pants? Now, when it means that they're all the same price, that means that the shirts are all the same price and the pants are all the same price. Not they're all the same, because that wouldn't make sense. So, first you just need to understand, okay, I'm going to have my shirts be my pants. My shirts be my x, my pants be my y's. Then create an equation that shows that. So, for Sam, it would be 4x for the shirts plus 3 pants for the y, which equals $181. And for Jenna, it would be x for the 1 shirt plus the 2 pants for 2y equals 94. Set that equal, and this is your system equation, and you solve for x using the elimination method just because it's easier, or if you want to use the substitution method, whichever one works. That is it. That is pretty much all you have to worry about on this test, on this portion of the test. I know it's an hour long, but I just wanted to get through everything a little bit better. The video will be posted today, so hopefully the questions and all that and the test will be posted today. It's gonna just be probably 10 problems. So yeah, that will be it for this video.